So 3.3, rules for differentiation. So here, how do you actually take a derivative besides you tangent? The tangent equation, remember, instead of taking limit as x approaches a, there's two different equations we learned. So we had limit as h goes to 0 of f of x plus h minus f of x all over h. Remember this one?
Yes.
Okay. Alternatively, we also have the limit as x approaches a of f of x minus f of a all over x minus a. These are two different examples of how to take a derivative. So we're on page 11, 3.3. What if you don't want to do this whole baloney with like the limits and stuff? Is there an easier way? Is there a shortcut? Is there a rule? And the answer is yes. We're going to go through some rules. And remember, differentiation, what differentiation means, rules for taking a derivative. Differentiation literally is when you were talking about derivatives. And what is a derivative? It's the slope of a tangent line. Tangent line to your function you're interested in. So if I'm wanting to know how is my function changing with respect to time at every single point, I could actually make a second equation, a second function that's describing how the first one's changing, and that's the derivative equation. Okay, and just remember difference between tangent and secant. So I have a function, one that crosses in two places is called a secant, and if it's only touching at one point, just at one point, it's called a tangent. So when I'm saying we're having a tangent line, it means the slope is only going to be touching one point of my original function. Okay, so derivative of a constant function. If f is the function with the constant value c, blah, blah, blah. Literally, if you have a constant, for example, what about y equals 3? What's the derivative of y equals 3? 0. Because if you think about it, what does y equals 3 look like? It's a flat line. What's the slope of a flat line? 0. Oh my gosh, amazing. All right, so what this literally means is y equals 3. And another way to say it is f of x equals 3. Right, literally, it's going to be, it is a flat line, right? This is, 1, 2, that's 3. So this is the equation of y equals 3. And we already know the slope of a flat line is 0. What about if I said d dx of pi? What is this going to be?
Circle.
A circle, 0? Did you say a circle?
Yeah.
Okay, cool. So it's 0, because once again, it's just a flat line. How about if I do like d dx of 1,000? What is this equal to? 0. And just a reminder, because I know it's been a hot second since we've actually been meeting. So d dx means take the derivative. So if I say d dx of pi, literally take the derivative of y equals pi. Oh wait, y equals pi is just a flat line. We know the slope of a flat line is 0. So anytime I'm asking you to take a derivative of a number, right? So if f is a function with a constant value c, so f is your function. C is literally any real number. Why am I specifying real number? Because there's things called imaginary. Okay. Yeah, so literally any real number, whether it be whole, integer, natural, rational, irrational. Okay, so C is any real number. All right, so far we're okay, because you already knew the slope of a flat line. Okay. What about if we do power rule for positive integer and rational powers of x? Okay. So if n is a positive integer, meaning the exponent, literally, how do you find the derivative? You take n, bring it down front, and then you just subtract 1 from the exponent. So my example, d dx of x to the 5th. So you're taking a derivative of x to the 5th. All right, so we bring the exponent down and multiply it times x to the, well, you subtract 1 for the exponent, so 5 minus 1. This is literally going to be 5 times x to the 4th. Ooh, it's called the power rule. This is the most useful. Yes.
Do you know what each one is?
You don't need to know what it's called, but if I give you,
Let's say, like,
you need to know how to do it.
did you ever ask us, like, to use a specific one?
I mean, I'm not gonna outright say it, but if I'm like, hey, take the derivative of x to the fifth, you're gonna be using the power rule. Like, you have to know how to apply them. And like when I grade your quizzes and tests, and sometimes on your homework, if I'm feeling like I want to spend a long time grading, I'll give feedback and be like, you can't do this, blah, blah, blah. Or think about this, like I'll give the reason why. That way you can look back in your notes and be like, oh, I see the actual explanation. I think there's a couple people where I'm like, no, that's not how you take the limit. It's, a constant times a function or something. Yeah. So I'll reference them, but honestly, I'll give you a problem just like this where you have to do it. You have to apply it. Let's do another example. How about dx of x to 11? What would this be?
It will be 11x10.
Beautiful. See, you guys can do it. Look at you. And if we would do the whole, like, remember the derivative, definition derivative, as x, see, limit as x approaches a of f of x minus f of a all over x minus a, blah, 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 like that whole thing. If you use x11, you'd get the exact same answer. Oh my god, same answer. On the quiz I just handed back, it was like the number 2. Remember when you're finding the equation? Remember the quiz I just gave you? Yeah, the number 1 and number 2, and you're finding the equation, the derivative. Surprise! This is much faster, sometimes. Okay, so that's just power rule. Notice I don't have a number in front of x, not yet. And that's because we have to talk about the constant and multiple rule. Okay, so this looks like gibberish, right? You're like, what the heck? There's so many different letters. But just like, bear with me. So if u is a differentiable function, meaning I'm just like putting in u as a little placeholder. The point is I'm multiplying a function by a number. So for example, if I, instead of having x to the fifth, what if I had like 4 in front? 4x to the fifth or something, right? If I had a number already in front, okay, how do we deal with that? We know how to deal with x to some power, but what about if there's a number in front of it? What do we do? Okay. What you do is you just multiply, you just bring the constant out front. It's just like when we were taking a limit, and you're like, oh, if you're taking 5 times x, and you're taking the limit, okay, you can just do 5 times the limit of x. You know, we always bring the constant out front. Yeah. So you can bring the constant out front and then take the derivative of the rest of the function. So here I have a 4 in front. So this is going to be the same thing as 4 times the derivative of x squared. Wait, how do I figure out the derivative of x squared? The power rule. So I bring 2 in front, and what is 2 minus 1? 1. Oh, okay. So then I just have to multiply the constant by my derivative of the function. 4 times 2x is going to be 8x. Yeah, let's do another example. Yeah, let's do it. Let's do it. How about Shani, give me a number.
6.
Ty, give me another number. 3. Okay, here we go. So first, bring the constant out front. And then if I want to take the derivative of x cubed, you bring the 3 down, and you subtract 1 on the exponent. So this would just be 18x squared. So you notice this like middle step right here? I'm literally showing you the rule. You could skip it and go straight to this if you wanted. You're feeling okay so far? Yeah, it's a lot of rules. Okay, Hannah, you gonna put your computer away? Thank you. All right. Okay, so far we've done a constant. What's the derivative of a constant? What's the derivative of a just plain? Positive integer, rational power. What about if I have a constant in front of it? Now, what about if I'm adding 2 different functions? Oh my gosh. So if u and v are differentiable functions of x, their sum and difference are differentiable at every point. blah, blah, blah. Literally what we're saying is, hey, what if I don't just have x squared? What if I have x squared plus x minus 2? What if I actually have a whole quadratic formula? A whole quadratic equation? Okay, so what you can do is just take it term by term. Take the derivative term by term. And this is if you're adding or subtracting them. Yeah? Okay. Just trying to like translate to make it a little easier because it's a lot of words. Oh my god, u, v, what the heck? Well, u, guess what? It's one of my functions. V is my other functions. Guess what? Look, here I'm adding them. What I can do is split it and take the derivative term by term. Awesome. So first, like more or less, I guess a way to think about this is we're like distributing the derivative. Like it's not actual distributing. You know what I'm saying?
I know what you're saying.
Okay, so it's not really distributing. It's the wrong word to use, but really it's like, okay, take the derivative term by term. Okay, I'll just write that so you see it. After I put your quiz grades in this morning, I went through the lesson and I was trying to figure out better ways to describe it. I just want you guys to understand. It makes me sad when you don't do well. Okay. So first, what is the derivative of a constant? 0. Beautiful. So 0. Plus, what's the derivative of this guy that I just underlined? 5 times 3.
The derivative of
Square.
Hey, okay, we're getting it. And then this is equal to?
15x squared.
Hey. Okay.
Yay.
Yeah, okay, whatever.
So,
Yep.
if it's ever adding, or I guess subtracting either, it's the same as the constant multiple rule, and it's just a number.
Right, because we're taking it literally term by term. And since this is one term, I just take the derivative of a constant, yeah. Let's do another example, yeah? Just so we really dig this down. Sorry, this is not written there. Let's see, dx of, let's make it interesting. How about 4x to the 5th minus 3x squared plus x
Do it.
minus 2. There we go. Okay, that's a lot. That's a big one. So what I'm going to do is take it term by term. So d dx, I think I wrote a little too big, of 4x to the 5th plus d dx negative 3x squared plus d dx of x plus dx of 2. Okay, what would this first one be?
20x4.
20x to the 4th. What about the next one? Minus 6x
0.
plus 1, because remember the derivative? Okay, trick play, okay.
That's 0.
Yeah, so this 0 is from this guy. Trick play. So here, let me change colors. So here, this was, it's not far enough. There. This is x to the first power, right? So I bring the 1 down, so now I have 1 times x to 0. What's x to 0? 1. So that's why it's just 1. Cool. All right, so this is our little answer. Just so far, so good. All right, now let's go through and let's find dy dx. So we do it term by term. Yeah. All right, I want you guys to try out A. If you're done writing, try out A. Now see pencils, moving across the paper, try out A. What's wrong? Are you done writing?
Oh, I just said it might be sorry.
Oh, okay.
Is mine different?
No, should not be.
No, I left the page right. Okay, that was me. Wait, what?
Oh, it's minus 1.
So we're taking the derivative. Remember the power rule. It's literally whatever your power was times x to the power minus 1. So dy dx is going to equal 12x to the 3rd minus 18x squared. So I'm going to do this in two parts. So I have 1/2 times 2x to the first minus 1/3 times 1 plus 10. So this right here is 1/2 times x squared.
Didn't the last one be 0? Yeah, right?
Yeah.
Where's that slope at?
I think I wrote an extra line for my plus. Too far over, I'm sorry. Minus 18x squared. That guy goes away.
Can you explain the x squared over x minus x plus 1?
Okay, which part? This part right here?
Yeah.
These two? Okay. So, this is the same thing as saying 1/2 x squared minus 1/3 x. Alright, so constant rule, so I have 1/2 times the derivative of x squared, which is just going to be 2x to the first. 2 times 1/2 goes away. So I'm just left with my x. And then here, this is negative 1/3. Let's see. Times, well, the power of the exponent was 1, so I bring 1 down. Times x is 0, well, that's just 1, so it's just going to be negative 1/3. So I see you were confused. Is that confusion erased? Maybe. So the trick part is, oh, x squared over 2. That's literally just 1/2 x squared. Okay. Let's try the next one. Woo! Okay.
Sorry.
No, it's cool.
Just leave it up there.
Yep. Yep, I will. Try out B. Give it a shot.
Do you have to put like the x1 or like x0?
No, you don't have to, but I'm trying to show you guys. Like trying to explain why. I'm showing all of my steps just so we can see. I'll write it a little differently because this means the same thing. And when you're done, go ahead and check your work on the board. So dy dx, this means the same thing as y prime, same thing of f prime of x. Those all mean derivative. Alright, so if your work doesn't match this, see where it went wrong, see what confusion we have. I can better help you if we know where the confusion is.
Where
Yep.
did the 4x?
Hannah?
So the derivative of 7x is 7x.
7.
0.
Sorry, 7, x is 0 because x is 0 is just 1. So 7 times 1 is 7 times 1 is 7. So I'm showing you how this was x to the first, minus 1 is x to the 0. I'm showing why, like, there's no x on the last term. Cool, cool, cool. All right. If you're done with B, sorry, do we need more time? Okay, so example 2, find the horizontal tangents of the curve, meaning we have to set the derivative to 0. So first thing we have to do is find the derivative. We have to find the derivative, and then we can set it equal to 0. Okay, so I need the derivative, so dy dx. We can just use the power rule. So you bring the 4 in front, so I have 4x, and then you do the power minus 1, so 4 minus 1 is 3. Bring the power in front, negative 2 times 2 is negative 4. And then subtract 1 will just be x to the first, and then the derivative of plus 2, well, it's a constant, so it's 0. Okay, so guess what? We're trying to find Like find where the horizontal tangents of the curve are. Horizontal tangents. Horizontal tangents. Wait, horizontal tangents. What's the slope of a horizontal tangent? Horizontal tangent, what's the slope going to be if it's horizontal?
0.
0. AKA, we're saying the derivative equal to 0. And I have to find for what x values
Wait, is it always 0?
the slope of a horizontal line is always 0. So, yeah, because a horizontal tangent, it's like, oh, literally where your slope is horizontal, where it's 0. Okay, so I'm setting it equal to 0, so I found the derivative, check. Now I have to set it equal to 0 to find the x values where the derivative would be 0. So how do I actually solve this?
Take out a 4x.
Beautiful. Take out a 4x. Literally, we're going to fully factor it. Fully factor. So this is x squared minus 1. Can we factor this further?
X squared minus 1.
Oh my gosh, difference of squares. And you know I love difference of squares. Because it's, I don't know, it's so much easier to factor. Okay, cool. Now, let's see. So this would be x equals 0. This would be when it equals a positive 1. And this would be when it equals a negative 1. Those are the 3 places where my derivative is 0. Where if I was drawing horizontal line, if I was drawing my tangents on my original function, that's where it would be a slope of 0. Yes, Elliot?
Well, on like the test or whatever, would you put set derivative to 0, or do we have to know that?
Well, I did give you a practice test, so. Cool. I'm trying to eliminate questions like that where you could like look yourself and see how I ask. So I'm going to try to keep the wording similar. Product rule. Okay, so we learned how to do power rule. You just bring down the exponent, subtract 1 from the exponent. Product rules, what if you're not just multiplying by a constant, you're multiplying by another function? So the product rule, literally it's going to be, you take your first equation, your first function, multiply by the derivative of the second. And then you're going to add, let's see, the derivative of the first times the second. Why is this not writing nicely? Let's see. First derivative times second. So that's what this is saying. U dv plus v du. So if you're multiplying two things together, literally look at this example here. I have 2 factors. I'm multiplying 2 functions together. How do you actually deal with this? Well, you take the first function, multiply it by the derivative of the second. Then you add the derivative of the first function, multiplied by the second. That's what this right here is saying. You take your first function, multiply by the derivative of the second. Then you add the second function times the derivative of the first. So an example of this one, let's see. So here, this is standing for my u, and this is standing for v. What is the derivative of u? What's the derivative of 2x plus 1?
2x. 2.
It's just 2.
1.
It's just 2. Yep. What's the derivative of v? 3. Now we know everything we're going to be multiplying by. So u, we said, was 2x plus 1 multiplied by derivative of v. Well, we said that was 3.
Oh, yeah.
Add v, okay, well, v was 3x minus 5 multiplied by derivative of u, which we said was 2. So distribute this out. 6x plus 3 plus 6x minus 10. And combine like terms. Perfect. So when you're multiplying 2 functions together, this is what you do.
What will you eat for Halloween?
What? Is that
What will you eat for Halloween?
me?
Yes.
You think I'm gonna be the product rule?
Oh, obviously.
Is that your question? I don't know. If you look on the back, it has the product rule for you. Was that your question?
No, she meant like, what are you gonna do for Halloween?
Oh, cool.
What did
Okay.
you think it was? She thought, are you gonna be the product for Halloween?
I was confused.
I thought you were saying like, duh, I'm obviously gonna be a product.
Nope. Nope. Okay, that's a product rule. You're taking, I'll answer this after we finish where I want to be. Okay. So if we're multiplying two functions together, use the product rule. What if you're dividing two functions?
Didn't we already do that?
The quotient rule. Quotient rule. All right. So as long as, so you have u divided by v. As long as v is not equal to 0, because remember that's undefined, where we have vertical tangent, can't divide by 0. The quotient, y equals u over v, of two differentiable functions is differentiable. Okay, what the heck does that mean? You have two functions. You can take a derivative of this one alone. You can take the derivative of this one alone. What if you divide them? Oh, guess what? Cool, you can take a derivative as well, as long as you're not dividing by 0. So, ooh. I don't want to sing this to you. I'm not a singer, especially screencasts.
Hit it.
Nope.
3, 2, 1.
It's, oh my god, I don't want to do this.
No,
Count down,
3, 2, 1.
I really like.
What's the melody? And I'll do it with.
Pop the weasel. Pop goes the weasel.
I really learned by listening to songs.
I take
Hi, D-Lo.
cross the line and square the low.
Perfect. I'll give you a point for singing it. Thank you, because I don't know. Yeah, well, you should
I want to sing
have.
it better. I want to sing it better.
All right.
Just 1 point.
All right, let's all do it together. Ready? Go. Low, D, high, take high, D, low. Cross the line and square the low. Wonderful.
There should be more to it.
Yeah, well, there's not, luckily. Do you want it to be longer? Like, think I spent.
You are so mean to me.
No, that was great. I clutched. Hannah came in clutch. Okay, so if you go, guys, that was beautiful. So if you go on the YouTubes, there's 50 different people who have versions of this, and I couldn't find one I was super happy with because the best version was made by a kid I had in Calc BC last year.
No way.
It was the best. It was the best, and I'm trying to find it.
Daniel Schiller?
No,
Definitely.
Bradley. Yeah, it's the best one. It's amazing. All right. So what the heck does this mean? So you low, d high. So you take the low one, v, times derivative of u. Then you subtract the top one times the derivative of the bottom, and it's all over the bottom one squared.
What do you mean take?
So you have low, d high. So you're taking the low one, the one on some bottom, times the derivative of the one on that's high, that's the top. Take means subtract. High, so the top function, multiplied by d low, so derivative of the low one. Cross the line, and then you square the bottom one, the low one.
Let's do this.
Okay, so we're gonna go over this one together. Okay, so here d is standing for derivative. All right. So how do I want to write it? Okay, I'll write it over here. So literally, you have denominator times numerator's derivative minus numerator times the denominator's derivative all over the denominator squared. What? Yeah. That's it. There you go. That's how you find it. Okay. So here,
Go back to the little thing you did.
okay. All right. So let me just list out what u and v are. So what is u? X minus 4.
X minus 4.
What's u prime? What's the derivative of this? 1. What's v?
2x.
2x. What's the derivative of v? 2. Now we have everything. We just plug in. Amazing. So, u, 2x, times u prime 1. I'm going through this part right here. Step by step. I listed what v was. I listed what u prime, the derivative of u was. Just plugging in right now. Just plugging in. All right, minus u, which is x minus 4, multiplied by v, which was 2, all over v, which was 2x squared. Now it's just algebra, where we just simplify. 2x minus 2x plus 8 all over 4x squared. Don't forget, distribute the 2, and then I distribute the negative out. So this is just going to be 8 over 4x squared. But we can simplify that further into 2 over x squared. Awesome. Cool, let's keep going. If you are done with this, writing this down, try out example 3, which is directly below. See if you can figure this out. We're applying the quotient rule. We're applying the quotient rule. Where are you looking? Down here? Yes. Sorry, am I good to scroll down? Are we okay? Okay. So, trying to find the derivative. Well, you're going to be using the power rule, like for the first line. Yeah. And I do this every time because then I don't really have to like think about it as much because I literally have it listed for me. Equals x minus 1, b prime 1.
What is V and V stand for?
So v is standing for one of my functions. V is the one that's on bottom here. U is...
That V is bottom and U is top. So you just gotta kind of know that. How do you pick the letter? Just like denominator.
Well, it's 3 letters, 4 letters, whatever, 17 letters instead of 1. So mathematicians like to simplify and like use shorthand as much as possible. Yep. Okay. How are we doing so far? So ideally it's not just like copying this down, like I want you to really try it. I think sometimes we get in bobblehead mode, we're like, and then you get home and you're like, I have no idea. So my focus for the next at least week is really make sure like you are trying them and you find the sources of where we're confused before the test. Yes?
I thought at the bottom where you have x minus 1, it would be x squared plus 4x. Because isn't the denominator squared? Oh.
It's v squared.
Oh.
So,
Yeah.
I mean, like FOIL it out. You don't have to. I mean, you can, but I'm just gonna fix the top.
Leave it that way?
I'm not done,
Oh.
but I have to simplify the top. So I'm gonna simplify. So I need to FOIL this out. So this is 2x squared plus 4x minus 2x minus 4 minus x squared minus 4x. So I'm gonna simplify the top one, the bottom. I mean, because it's a rational function, right? Okay. Okay, 2x squared, so it's just going to be x squared. Cool, I've dealt with those. And then 4x minus 4x, okay, those just go away. And I'm left with negative 2x. And then, oh, minus 4. That's it. You could, so you could leave it this way, or you could fully, like, I mean, you could factor it if you want, but the top one isn't nice. The top one, you have to use a quadratic equation. So, you could FOIL out the bottom. The main part is, like, simplify the top, because, you know, some of the stuff, like, went away. Combine, like, terms. That's what I want.
2x squared minus x squared is x squared. Oh, got it.
Yep. So we know that this is a rational function. And then what we found right here, this is the formula for slope of a tangent at any x value. So what did you actually find here? I just want to make sure you understand what you're doing. So by finding the derivative, you literally found the equation that will spit out the slope to you. Any x value you pick, it will tell you exactly what the slope is going to be for your original function. Yeah. 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 Okay. Power rule for negative integer powers of x. Not a lot. Just split it up because to make it, try to make it a little easier for you. If n is a negative and at least x doesn't equal 0, literally you bring the exponent in front and then you subtract 1 from the exponent. Okay, so why is this? Why did I separate it out? Let's see what happens. So I bring the exponent in front. Okay, so I have 3 times negative 4 x to the negative 5th. Okay, so what do you mean what?
Minus 1.
Yeah, this is why I put it separate, because when you subtract, you get more negative.
You almost did me like that.
Gotcha. All right, so I have negative 12 x to the negative 5th. Wait, negative exponent, I can literally rewrite this as negative 12 over x to the 5th. So it's the same like power rule, it's just tricky trick. Subtracting 1 from a negative. Okay.
You need to make it.
I mean, you're going to be going through it with your homework and stuff. Okay, there's another question. Noah? Why are you talking? Okay, only Noah. Okay.
Like all the time, so you can leave it as negative 12x.
This is simplified. So you should write it that way. Was that your question, Spencer? Yeah. Yeah, just that way you see it on the bottom. Okay, so I don't think we have enough time to do example 4. It's just applying quotient rule again. But we'll finish these next. So honestly, if we had 5 more minutes, we could finish this one. And then this guy is super easy. You just, oh, you took the derivative the first time? Take it again. Take another derivative. Okay.